Hello dear students. So if you can recall what we have covered in the last video. So I told you about charges, I told you about the properties of charges, I told you about the types of charges which are there. So let me just recap it once. So the properties of charges that we have discussed. So the properties of charges that we have done was, number one, that charge is always quantized. Quantized means that Q is equal to number of electrons into charge on one electron, where this E is a fundamental constant having a value 1.6 into 10 to the power minus 19 coulomb. Then we have done another property, which is that charge is additive in nature. You can straight away add charge like you add scalars. So it is additive in nature. And the third very important property was charge conservation. So the third very important property was the charge conservation. So this is what you have done in the last video. Now, so the next thing that we are going to understand is what is the process of charging? What is the process of charging? So what exactly is charging? So class, when I say charging basically means that you have to give charge to a body. So how do you charge a body? There are three methods for that. So there are three methods of charging. To give charge to a body, there are three methods, which is number one, conduction. You must have heard about this, conduction. Number two is induction. So conduction, induction, and then there is charging by rubbing. You must have heard that when you rub two bodies, then one of them acquires a positive charge, the other one acquires a negative charge. So these are the general three methods. So we have conduction, induction, and then we have charging by rubbing. So let me start with the first method, which is conduction. Now when I say conduction, what does conduction refers to? So the word conductors, you must be aware of this word, you must have heard it before also. Conductors are those substances which possess free charges, which possess free electrons, or I should say. And when I say that somebody is conducting, so conduction basically refers to the flow of charge. So when I say conduction, so conduction refers to the flow of charge from one body, the flow of charge from one body to another. So conduction refers to the flow of charge from one body to another through a contact between them. Which basically means that when there are two bodies, let us suppose one of them does not carry a charge and one of them carries a charge. So you put them in contact. Say for example, there are two objects. Let's say there are two spheres. Suppose this is sphere A and let us suppose this is sphere B. Say sphere A is carrying a negative charge. Now why it carries a negative charge? I hope you know the reason of charging. I have discussed in the last class. This sphere is negative because it carries more number of electrons than protons. We have given many electrons to sphere A. Now if sphere A is negative and this sphere initially is neutral, so this sphere initially is neutral. So when you put both of them in contact with each other, so there is a direct contact, there is a physical contact between A and B. So what will happen is that some of the electrons of A will flow to body B. So there will be an electron flow from body A to B, from A to a sphere B. Now this flow will take place till the time the charge on both the bodies will be equal. Now the charges are only equal if the two spheres are made up of same material and they have the same size. So till what time will this charge be transferred? That actually depends on the size of the two spheres. There is something known as a potential. The charge is transferred till the time the potential becomes same. But let me not go into details of potential right now. Let us assume that if the size of the spheres is same. So let's just suppose that if size of spheres is same, in that case Q after conduction, what will be the charge on both the spheres after conduction? That will be equal to, let us suppose Q1 is the charge on the first sphere before conduction, Q2 is the charge on the second sphere before conduction, which in the example which I have discussed is 0, divided by 2. So you have to take the average of the charges. For example, Let us suppose that there is a sphere A which carries a charge of 5 microcoulomb. Let's suppose there is a sphere A which carries a positive charge of 5 microcoulomb, and there is a sphere B which is neutral. It carries 0 charge. But they have the same size. Let's suppose the size of A and B are same. So A and B have the same size. Now if you put them in contact, let's suppose if A is made to come in contact with the sphere B, if there is a contact between A and B, now if I ask you what is the charges on both of them, in that case A and B will have a charge of plus 5 by 2 and B will also have a charge of plus 5 by 2 microcoulomb. So what is going on? So you have to remember one thing, that during conduction it is the same nature of charge which gets accumulated on both the spheres. So whatever is the charge on A, if A is positive, then B will also be positive. If A is negative, then B will also be negative. This is an important point over here, that charge after conduction. So once the conduction occurs, so after conduction, the charges on both the spheres will be the average of the two charges if the size of both the spheres is same. If the size of the spheres or if the nature of the spheres is different, in that case, this will not be the answer. In that case, we have to equalize, we have to equate the potentials basically. In that case, the potentials on both will become same. And how to do that potential, that we'll do in 4th chapter. Right now, you just remember, after conduction, if the spheres have the same size, charges after conduction on both of them will be the average of the two charges. Okay, now, so important point is that charging, there is a physical contact between the two spheres. There has to be a contact. So there is a physical contact between the two spheres, and number 2, it is the same nature of charge which is produced. So it is the same nature of charge is produced. So this is an important point regarding conduction, that the charge produced is of the same nature. Now the second thing that I am going to discuss over here, the second method is induction. The second method of charging a body is induction. So the second method of charging a body is charging by induction. Now when I say induction, so the basic difference between conduction and induction is, in conduction there is a touch, the two spheres are touching each other, whereas in case of induction there is no physical contact, there is no touch, there is no physical contact between two bodies. There is no physical contact between two bodies, and without physical contact, if one of the spheres carries a charge, the other one will also carry a charge. But again, what is the difference? Important point is that there is no physical contact between the spheres, between the two bodies. And second very important point, that the charge produced will be of the opposite nature. The charge produced will be of the opposite nature. In conduction, the charge was produced of the same nature, like if A is positive, then B was also positive. But in case of induction, the charge produced will be of opposite nature. So I'll explain you how it works. Let us suppose there is a sphere A again. Suppose this is sphere A, and this sphere A, say, carries a positive charge. On the other hand, there is sphere B which is neutral. So sphere A is carrying a positive charge, whereas sphere B is neutral. Now neutral does not mean that it does not contain any charge. Neutral means that B sphere has equal negative and positive charge. Now when a positively charged body is brought closer to a neutral body, there is no touch over here, but it is just brought closer to a neutral body. So the negative particles of B, whatever is the negative charge present in B, that gets attracted towards the positive charge of A. So the negative charge of B gets attracted towards the positive charge of A, and the positive charge of B is repelled by the positive charge of A. So as you can see very clearly, initially negative and positive of B, they have the same center. But when I brought a charged body, a positively charged body near to a sphere B, then there is a, you can say there is a dipole which is induced. What is a dipole? In chemistry you study this, that there are two poles. So over here also, in body B, the negative shifts on one side, and that side will be nearer to a positively charged sphere A, and positive will shift to the other side. Now let us assume that if to this sphere which is negative on this side and positive on this side, if to this sphere I ground it. So this was sphere A. Sphere A was positively charged. This is the condition of sphere B. Now I connect it to the ground. I connect sphere B to the ground. Now what is ground? So ground, what will it do is, ground will see that B sphere is positive. This negative is in attraction with A, whereas ground will see that some body, some positive body is connected to ground, and through this wire what will earth do? Earth will neutralize this positive charge on the sphere B by providing electrons from the ground. So earth will provide electrons, these negative charges. It never happens that this positive will go into the ground. In some books it is written that positive goes to the ground. It is in fact the negative. It is always the flow of electrons which take place. So earth will provide a negative charge to neutralize this positive half of B. So this positive half of B is neutralized, and why this negative does not go into the ground? Because this negative is held by the positive charge of A. So what will happen is that these electrons will neutralize the positive charge, and now if you look at body B, if you remove A and now if you look at body B, its positive is neutralized by the earth, and in a way B becomes negative. So A was a positive sphere, so the positive sphere produces two charges. I mean it induces a polarity of negative on one side and positive on the other side, and when you connect B body to the ground, this positive charge is neutralized by earth, leaving a negative B. Now let us suppose that if A would have been negative, then positive would have come on this side, negative would have come on this side, and then if I would have connected B to the ground, the negative charge of B, the excess negative charge which was on this side, would flow to the ground, leaving positive B. So that is what I am trying to explain, that there is no physical contact and the charge produced will be of the opposite nature. If sphere A is positive, then B will become negative, and if sphere A is negative, then B would have become positive. So that is the main point. In conduction, the two charges are of the same nature, but in induction, the charges induced are of the opposite nature. Now one very important question which I would like to tell you over here is, see, I have just drawn a figure over here and I have told you that if, let us suppose, sphere A is positive and this B is a neutral body. If this B is a neutral body, it carries no net charge. A carries a positive charge and B is a neutral body. Then I have just told you what will happen. The negative of B will shift on this side. The positive of B will shift on this side. Now if I ask you that whether A will attract B, or whether A will repel B, or whether nothing will happen, what do you think? So if you think slightly, because this negative charge of B is more closer to the positive charge of A as compared to the positive charge of the B, जो हमारा B का जो negative charge है वो A के ज़्यादा close है as compared to B के positive charge के. Therefore this negative and this positive have a strong attraction. So this negative and positive have a strong attraction between them. So attraction between negative of B and positive of A is more stronger as compared to the repulsion between positive of B and positive of A, due to which there is a net attraction. Due to which there is a net attraction of B by body A. So body B will be attracted towards A only. So B is a neutral body. So even a neutral body gets attracted towards a charged body. So even a neutral body gets attracted towards a charged body. So if I ask you that some body is being attracted by the other, then are you sure that that body is charged? You know, B will be attracted towards A. Definitely if B would have carried a net negative charge, then it would have definitely got attracted towards A. But even if B is neutral, in this example, even if B is neutral, it is still being attracted by A. So attraction is not the shear test of charge. So if a body is being attracted, so attraction is not the shear test of charge. Please understand this point very carefully. Attraction is not the shear test of charge. The reason is because a neutral body is also attracted. It is because a neutral body is also attracted towards a charged body. It is because a neutral body is also attracted towards a charged body. So therefore, if a body is being attracted, you cannot say that it is definitely carrying a charge. Why? Because a neutral body is also attracted. Only if it feels repulsion. B will only be repelled by A if B carries a net positive charge. So we can conclude from this point that repulsion is the shear test of charge. This is an important line. It comes as a 1 mark question, that what is the shear test of charge and how you can prove it. So you can prove it in this manner, that you can take a sphere A which is positive, and this positive sphere will induce negative on the left side of B and positive on that side of B, due to which this B will be attracted towards A only. So B is neutral, but it is still getting attracted. So you are not sure whether attraction, if there is attraction going on, then you are not confirmed that B is charged. It may be neutral also. You are only confirmed that B is charged only if it feels repulsion. So we can say that repulsion is the shear test of charge. So we can say that repulsion is the shear test of charge. So this is a very important point. Do remember, repulsion is the shear test of charge. So I hope you are clear with the two important methods of charging. Number one is conduction. In conduction, the charge induced is due to physical contact between the two spheres. The charge produced will be of the same nature. In case of induction, there is no physical touch, there is no physical contact, and the charge produced will be of the opposite nature. If A is positive sphere, it will induce a negative charge on B. If A is negative sphere, it will induce a positive charge on B. Now let us go to the third method, and that third method was charging by rubbing. Very important method, and that is charging by rubbing. So in younger classes, in maybe in 6th or 7th class, you did that activity. You rub comb with your dry hair and bring it closer to the bits of paper, and those bits of paper are attracted towards the comb. So that is an example of electrostatic attraction. So what is actually going on in that process is that comb is being charged by your dry hair. When you rub it strongly, it acquires a charge. So how body acquires a charge? By rubbing. So how body acquires charge? By rubbing. So charging by rubbing. How this is done? Now, very important force which is responsible for this is friction. Without friction, by rubbing, you cannot produce charging. So friction is the force which is responsible when you are producing charging by rubbing. Now what is the role of friction over here? What is the role of friction over here? So children, I hope you know that friction is the one. Let us suppose if you take your two hands and you rub it together. If you rub your two hands together, then what are you doing? You are doing a work, and this work is being done against the force of friction. It is friction which does not want that you rub your two hands. But if you are still rubbing your two hands, you are working against friction. And what will happen? So when you rub your two hands, what happens? It produces heat. It produces energy. So in the same way, when we rub two bodies on rubbing, when we rub two bodies, what happens? Some heat is produced. Some energy is produced. So on rubbing, some energy is produced. So on rubbing, some energy is produced. Now, if the energy produced is, let us suppose there is body A and there is body B, and I am rubbing these two. Both of them are neutral. Let me tell you, both of them are neutral bodies. So A is also neutral, B is also neutral, and I am rubbing them together, and they must be different bodies. It cannot happen with the same bodies. They have to be of different natures. So if these are two different bodies, so if these are two different objects, if these are two different bodies, and I rub them together, let us suppose that A has a lower work function. Let us suppose that A has a lower work function. Now I have just used a term over here, work function. Now what is the meaning of the term work function? Children, work function basically क्या चीज है? Every body needs some energy to lose electrons. You all know that A cannot lose its electron as such. It needs some energy so that it can lose electrons. So how much is the minimum energy required so that a body can lose its electron? That is what is called work function. How much is the minimum energy required so that a body can lose its electron is what is called work function. Now let us suppose that A और B bodies को हमने जब rub किया, इससे कुछ energy produce हुई. Suppose कर लीजिए 10 joules की energy produce हो रही है. So this is the energy produced. I'm just taking an example, a rough example, so that you can understand. लेट अस सपोज 10 जूल ऑफ एनर्जी इज प्रोड्यूस्ड व्हेन वी रब ए एंड बी टुगेदर। मान लीजिए ए का वर्क फंक्शन है 2 जूल्स का, सो 2 जूल्स इज वर्क फंक्शन ऑफ बॉडी ए, और बी का वर्क फंक्शन है लेट अस सपोज 11 जूल्स का, 11 जूल्स वर्क फंक्शन बी का है। सो व्हाट इज गोइंग टू हैपन, व्हाट डू यू थिंक इज गोइंग टू हैपन? सो एनर्जी प्रोड्यूस हुई 10 जूल्स, ए को इलेक्ट्रॉन लूज करने के लिए एनर्जी चाहिए 2 जूल्स और बी को चाहिए 11 जूल्स। सो व्हाट इज गोइंग टू हैपन, हमारी एनर्जी 10 जूल्स है, तो क्योंकि ए को सिर्फ 2 जूल्स की ही एनर्जी चाहिए इलेक्ट्रॉन लूज करने के लिए और हमने 10 जूल्स की एनर्जी प्रोड्यूस करी, सो ए बॉडी विल कंज्यूम दैट मच एनर्जी, ए बॉडी विल कंज्यूम एनर्जी एंड इट विल लूज इट्स इलेक्ट्रॉन। ए बॉडी अपने इलेक्ट्रॉन को लूज कर देगी क्योंकि इसको एनर्जी चाहिए सिर्फ 2 जूल्स की और इसको मिल कितनी रही है 10 जूल्स की, तो 10 में से 2 जूल्स की एनर्जी जो है वो ए गेन कर लेगी और वो अपना इलेक्ट्रॉन लूज कर देगी, और वो इलेक्ट्रॉन अगर लूज करेगी तो ए पे चार्ज आ जाएगा पॉजिटिव बिकॉज इसने अपना एक इलेक्ट्रॉन लूज कर दिया। अब वो इलेक्ट्रॉन ऐसे हवा में तो नहीं जाएगा, तो ये इलेक्ट्रॉन जाएगा कहां, जिसके साथ आप रब कर रहे हो, बिकॉज देयर इज अ कॉन्टैक्ट बिटवीन द टू, दिस नेगेटिव विल गो टू स्फीयर बी। So in this way, when you are rubbing two bodies, friction is responsible. Friction अगर नहीं होगी तो चार्जिंग नहीं कर सकते हो आप। So when you are rubbing two bodies, because of the friction, energy is produced. That energy should be more than work function of one of the two bodies. तो जिसका वर्क फंक्शन कम होगा, लाइक इन माई एग्जाम्पल ए हैज अ लोअर वर्क फंक्शन, सो जिसका वर्क फंक्शन कम होगा वो अपना इलेक्ट्रॉन इजिली लूज कर देगी एंड दैट बॉडी विल एक्वायर अ पॉजिटिव चार्ज एंड द अदर बॉडी विल गेन दैट इलेक्ट्रॉन एंड इट विल एक्वायर अ नेगेटिव चार्ज। सो इन दिस एग्जाम्पल बेसिकली बोथ ऑफ द बॉडीज आर न्यूट्रल एंड वी आर शिफ्टिंग चार्जेस, वी आर शिफ्टिंग इलेक्ट्रॉन्स फ्रॉम वन बॉडी टू अनदर। सो very important point to keep this mind is that work function जिस body का कम होगा, lower the work function, that body will acquire a positive charge, higher the work function, that body will acquire a negative charge. So there is an example for that. अगर आप if you rub glass rod with a silk cloth, then the glass rod will acquire a positive charge and the silk cloth will acquire a negative charge. So what does it basically mean? It means that glass has a lower work function, क्योंकि glass के ऊपर अगर positive charge आ रहा है तो glass का work function कम है और silk का work function ज़्यादा है। So that is what is the meaning of charging by rubbing. So direct question, it can come as a 2-mark question. Discuss charging by rubbing. सो आपको एक एग्जाम्पल से हो सकता है समझाने के लिए आ जाए। सो राइट अ ब्रीफ नोट ऑन हाउ यू कैन प्रोड्यूस चार्जेस बाय रबिंग। सो द इंपॉर्टेंट फोर्स इज फ्रिक्शन, फ्रिक्शन होगी तो एनर्जी प्रोड्यूस होगी जब हम दो बॉडीज को रब करेंगे, और वो एनर्जी इतनी होनी चाहिए कि वो जो दो बॉडीज को आप रब कर रहे हो उनके वर्क फंक्शन से कम हो। और अगर दोनों बॉडीज का वर्क फंक्शन सेम हो जाएगा, मान लो अगर इसका 2 जूल है और अगर इसका भी 2 जूल्स हो जाए, सेम तब होगा अगर दोनों बॉडीज सेम है, सेम नेचर की बॉडीज हैं। तो अगर इसका भी 2 जूल्स है, मान लो इसका भी 2 जूल्स है, देन दे विल गेट कंफ्यूज कि कौन सा इलेक्ट्रॉन लूज करे, तो वैसे केस में चार्जिंग नहीं होगी। सो यू मस्ट मेक श्योर दैट द टू बॉडीज आर डिफरेंट बॉडीज एंड जो एनर्जी प्रोड्यूस हो रही है वो एनर्जी दोनों के वर्क फंक्शन से, किसी के जो एक बॉडी है एक के वर्क फंक्शन से ज्यादा हो। तो जिसका वर्क फंक्शन कम होगा वो इलेक्ट्रॉन लूज करेगा, जिसका वर्क फंक्शन ज्यादा होगा वो उस इलेक्ट्रॉन्स को गेन करेगा। एंड ड्यूरिंग दिस प्रोसेस इफ n इज द नंबर ऑफ इलेक्ट्रॉन ट्रांसफर्ड, मान लीजिए अगर n हमारे नंबर ऑफ इलेक्ट्रॉन्स है जो ट्रांसफर हुए हैं, तो हमारा जो चार्ज आएगा दोनों बॉडीज पे वो आ जाएगा प्लस माइनस Ne। ये हमने लास्ट वीडियो में देखा था प्रिंसिपल ऑफ क्वांटाइजेशन। चार्ज जो आएगा वो आएगा प्लस माइनस Ne। प्लस Ne आएगा जिसने इलेक्ट्रॉन लूज किए हैं और माइनस Ne आएगा जिसने इलेक्ट्रॉन्स गेन किए हैं। एंड ड्यूरिंग दिस प्रोसेस देयर इज अ लॉस ऑफ मास ऑल्सो। So during this process there is a loss of mass also by A and gain of mass by B, because electron का भी कुछ mass होता है। So loss of mass by A, so loss of mass by body A will be equal to gain of mass by body B, will be equal to gain of mass by body B। और कितना लॉस है कितना गेन होगा, that will be equal to number of electrons। सपोज अगर n इलेक्ट्रॉन्स लूज हुए तो number of electrons multiply by mass of 1 electron। So you can multiply n with, I hope you all know the value of this mass of 1 electron, which is 9.11 into 10 to the power minus 31 kg। So in this way you can also calculate that how much is the mass transferred। So I hope you have understood these three methods of charging. I repeat again. So we have conduction, in which there is a physical contact between the two bodies. Due to the physical contact, the charge produced is of the same nature. If A is positive, B is also positive. If A is negative, B is also negative. Then the second one was charging by induction. So in induction, if A is positive, then B will acquire a negative charge. If A is negative, then B will acquire a positive charge. On the third hand, which is charging by rubbing, in this case both the bodies are neutral initially, but they have different work functions. You are rubbing the two bodies, and on rubbing, one of the body will lose electrons. The one will lose electron is that one which has a lower work function. So in that way, that will become positive and the other one will become negative. So I hope you are clear with how to charge a body. What is charging? Now the next thing that we are going to do is some point of differences between charge and mass. We have already done the differences between electrostatic force and the gravitational force, which is, you all know it very well, that gravitational force is always attractive, electrostatic force may be attractive or repulsive. So we have done all kinds of things. Now we are going to discuss what are the points of differences between charge and mass. What are the points of differences between charge and mass? So very simple differences are there. You can say that charge can be positive, it can be negative, or it can be zero. You know, it can be neutral, it can be positive, or it can be negative. Whereas mass, obviously it can never be negative or zero. Mass is always positive. Second point, very very important point, and this difference is very important. Charge is quantized. We have just done that charge is quantized. किसी भी बॉडी पे जो चार्ज होता है वो चार्ज हमेशा एक इलेक्ट्रॉन का ही मल्टीपल होता है. Q is always equal to Ne. But till date there is no such quantization of mass. There is no such quantization of mass. So till date there is no such quantization of mass. This is an important point. There is no such quantization of mass. Now next point, again very important. You cannot have charge without mass. जब तक किसी बॉडी का मास नहीं होगा तो उसके ऊपर चार्ज नहीं हो सकता. So charge cannot exist without mass. Charge cannot exist without mass. Charge cannot exist without mass. Whereas if I talk about mass, mass can exist without charge. You can have neutral bodies, so mass can exist without charge. Charge mass के बिना नहीं रह सकता, लेकिन mass charge के बिना रह सकता है. Mass can exist without charge. तो इससे रिलेटेड आपको कभी कभी शॉर्ट क्वेश्चन पूछा जाता है, डू फोटोन रेज कैरी एनी चार्ज? क्या फोटोन रेज पे कोई चार्ज होता है? सो यू मस्ट रिमेंबर दिस, दैट photon rays do not carry a charge. Do not carry a charge, and the simple reason for that is because they are basically energy. These are radiation. They do not have mass, so they do not carry a charge because they are massless. Because these are massless. You must remember this point. Photon rays do not carry a charge because these are massless. Then we have one again very important point of difference, which is that charge is invariant. I will just explain you what does this word means. Charge is invariant, whereas if I talk about mass, then you must remember that mass is variant. Mass is variant. Children, there is one relation which we do not derive it right now, but there is a relation in theory of relativity, and that relation goes like this. This is called mass relativistic formula. You know, whenever an object starts to move, it becomes heavier. There is a relationship in physics which we do in higher physics. It is not right now in your syllabus. It's just a short point which I will discuss over here. M is equal to m naught. What is m naught? M naught is the rest mass. Rest mass means when a body is at rest, then its mass is m naught. So m is mass when it starts to move. So mass when body moves. So when some body starts to move, when body moves, then its mass is different, and m naught is the rest mass. So this is the rest mass. So the relationship is that m is equal to m naught divided by under root of 1 minus v square over c square, where v is the velocity of the body and c is the speed of light. V is the velocity of the body which is moving, जिसका हम यहाँ पे मास लिख रहे हैं, और c is the speed of light which is 3 into 10 to the power 8. You know this is the fundamental constant, 3 into 10 to the power 8 meters per second. So according to this relation, if a body starts to move, its mass will change. Whereas for charge there is no such relation. Charge is invariant. Invariant मतलब जो वेरी नहीं होता, which does not change. लेकिन मास क्या होता है? मास इज वेरिएंट. मास वेरीज विद वेलोसिटी. आप वेलोसिटी चेंज करेंगे तो मास अलग आएगा. एक रुकी हुई बॉडी का मास होता है m0, लेकिन जब कोई बॉडी मूव करने लग जाती है और अगर उसकी स्पीड v है, तब उसका मास आएगा m0 ओवर अंडर रूट ऑफ 1 माइनस v स्क्वायर बाई सी स्क्वायर. So I hope this difference is clear to you. You are aware of now what is electrostatic force. You are aware of what is gravitational force. You know that it is the repulsion which is the shear test of charge. Attraction is not the shear test of charge. You know the differences between charge and mass. You know the point of similarities between charge and mass. You know the properties of charge, which is charge quantization. Then charge is additive in nature. Charge is conserved also. I will discuss one numerical here with you. Suppose if the question like this comes, it is also an NCERT example. If you follow your NCERT book, there is an example also like this. I'll just discuss with you that what is the positive and negative charge. You have to tell me both the charges, total positive and negative. What is the positive and negative charge in 250 milliliter, in 250 ml cup of water? What is the positive, what is the total positive and negative charge in 250 ml cup of water? So children, this is an NCERT example. This is an NCERT question that I am discussing. Very important again. So we have to answer in this question what is the total positive and negative charge in 250 ml cup of water. So there is a cup of water carrying 250 ml water. Now since you all know that water is a neutral species, water is neutral, so whatever is the positive charge, that much will be the negative charge. So because water is neutral, so since you all know that water is neutral, so the positive charge and the negative charge in water will be same. So the positive charge and the negative charge will be same. And how will you calculate the positive and negative charge? So let us try to calculate the negative charge. Same will be the positive. In order to calculate charge, we have to use the principle of quantization, which is if you know Ne, if you know the number of electrons which are there in 250 ml of water, if you can answer me this thing, that how many electrons are there in 250 ml cup of water, then you can solve this question, because E has a fixed value. You can calculate Q if you know what is N, if you know how many electrons are there. Now in order to calculate the number of electrons in 250 ml cup of water, I would first like to tell you that water is H2O. So in H2O, one molecule, you know H2O, if I write H2O, it basically means one molecule. One molecule of water contains how many electrons? Can you tell me? So one molecule of water contains H2O. So H2, so you know hydrogen has one electron, but it has two atoms. So 2 electrons of hydrogen and 8 of oxygen. So 2 plus 8, how many electrons are there in one molecule? There are 10 electrons. So 10 electrons are there in one molecule of water. So in order to calculate number of electrons, you should first calculate number of molecules. And in order to calculate number of molecules, we have to apply the mole concept that you study in chemistry, one of the most important concepts of chemistry. So in order to calculate number of